Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now let us learn about what is first law of thermodynamics and what does it states, as well as we are going to do what is the mathematical expression of first law of thermodynamics. So let us do it. So before understanding what is first law of thermodynamics, we should understand what are the statements of the first law of thermodynamics. So based on that, let us see the first statement, which says the total internal energy of an isolated system is constant. It has been said that the total internal energy of an isolated system is said to be constant. This means that suppose if we have taken a particular system which has been isolated, and as we know, because of the isolation of that, neither the energy can be exchanged with the surrounding or from surrounding to the system. So this clearly indicates that since the heat will not be, or since any kind of energy would not interfere with the presence of which is actually present in the system, so there would be no change in the internal energy, and hence the first law says that there would be no change if we are considering a system which is being isolated in the matter of in the means of matter or in the means of energy. So the first statement is clearly understood right now. So now talking about the next one, that is energy can be converted from one form to another form, but it cannot be created or destroyed. That is true, because it says that energy cannot be created, and the only thing is we could transform one energy to other form, but we cannot create a kind of energy, or we cannot destroy a particular energy. So that is what the second statement is talking about. So now let us learn about what would be the third statement of that. So the third statement says that the total energy of the universe is constant. Yes, that is fine, because the total energy of the system is a constant, because the energy cannot be created, as we know, and energy cannot be destroyed. So that means that no energy is being created, no extra energy is being destroyed. So that means the overall energy of the whole universe is said to be constant. So even this implies that we are talking about the first law of thermodynamics. Now let us talk about the last statement that we have with us right now. That is, the total amount of energy, or the total quantity amount of energy of a system and its surrounding must remain constant, although may change from one form to another form. So it clearly indicates that it is talking about the third statement, because as we know, because universe is basically the energy of the universe will remain constant. So for somehow, if we are talking about the fourth statement, if a particular amount of energy has been reduced from the system and it has went to the surrounding, or it has been evolved in the surrounding, then what happens? The amount of energy that has been reduced for the system will now be the constant value, while that of the surrounding we can see the energy has been increased. But the amount of energy that has been decreased in the system is nothing but the amount of energy that has been increased in the surrounding. So this clearly indicates that energy is not being destroyed in any case, as well as we could see that the energy are constant for both the cases, that is for the surrounding and the system overall. But yes, there would be an exchange with the surrounding and the system. The energy would be exchanged from both of them, but yes, the overall energy would be constant. So this is the first law of thermodynamics that we have got to learn now. So it is very much clear that what is actually the first law of thermodynamics. So let me give you more detail about this thing by giving you a mathematical expression, or by giving you a kind of example, so that we could get to know that what are we talking about. So now let us understand this thing, because we know recently that we have studied the statements of the first law of thermodynamics, and there we have got to know that the first law of thermodynamics is based on principle of conservation of energy. Just like the principle of conservation of mass, the mass cannot be destroyed or mass cannot be created, it would be the same. Similarly, for energy also, it is implying the same statement, that in first law of thermodynamics, it is behaving or it is obeying the principle of conservation of energy. So let me give you a short example of it. Again, I'll tell you, or I'll consider a cylinder enclosed with a gas and having a frictionless movable piston, as you could see. So this is the gas particles that have been present in the cylinder which has been enclosed through a movable and frictionless piston. And talking about the initial state of this, when we could see that this gas will have a particular volume, so that volume could be considered as V1, while that of the particular gas will have its own internal energy. And we know what is internal energy actually. Internal energy is nothing but the sum of all the energies that are being present in a system. Might be rotational energy, might be translation energy, or any kind of energy, might be kinetic energy or potential energy that has been present in the system. So this clearly indicates that we are now going to talk about the internal energy when it is present in the initial state. So let the internal energy be U1. So if I have to provide energy, because just now we have made a statement that energy cannot be destroyed or cannot be created, but yes, it could be transformed. So suppose if I have transferred the heat in this system, so what will happen? So once I have increased the quantity of heat in the system, in this kind of system, then what I could see is, I could see that because of the internal energy that would have been increased now, so that will lead to the increase in volume, because when I will heat this kind of system, then the collision will start, the gas particles will collide with each other, and hence the kinetic energy will be more. And the kinetic energy will be more, so that it will allow more pressure, and yes, now gas will expand. So if the gas expands, so initially it had a volume of U1, V1, but after the expansion, the volume will change. So that volume will be nothing but V2. But if the volume changes, then we know that even internal energy will have an effect of it, because internal energy is said to be a state function. And in this case, suppose if pressure and if volume, or if anyone changes, then it is but obvious that internal energy will also have an effect on it. And hence, so for that instance, let me give you a short example, and let us see that what have we done in this case. So in this case, what we have mentioned is that U1 is nothing but the initial internal energy, while V1 is the initial volume, and in this case Q is the amount of heat that we have provided to the system. So therefore Q is equals to, or is the heat provided to system. So after this process, what we have observed it as, there will be change in volume. So the volume will be changed to V2, that is the final volume that we will observe. And if this changes, then we know that internal energy will also change. So therefore in this process, what I have made it as, U2 is nothing but the final internal energy. So this is how we have made a statement, and we have segregated this terms like U1, V1, Q, V2 and U2. So now we could easily apply the first of thermodynamics, and what it would be, let us see. Now as we know, because the internal energy has been changed, so now when we are talking about the final internal energy, that is when we are talking about U2, so this final internal energy will be equals to what? It will be equal to the internal energy that was present in the initial state, as well as we have provided heat to that, so plus Q, as well as we could see that the volume has also been changed. The volume has been changed from V1 to V2. That means the system has performed a work, and that kind of work can be denoted in this way. And talking about the next thing, because there is a change in volume, means the work has been done in this process. So suppose if the work is done in this process, so we could write this equation as U2 minus U1, which is equals to Q plus W. But we know that is U2 minus U1 can be denoted as delta U, and in this case delta U is nothing but the change in internal energy. So now this was the change in internal energy that we have observed, that is U2 minus U1 is nothing but the delta U. So I could write this equation as delta U is equals to Q plus W. So this implies that if we change the internal energy, then that kind of change in internal energy will be accompanied by two factors, that is it will be because of we have provided heat to the system, as well as in this case when we want that there should be increase in internal energy, that means the work should be done on the system by the surrounding. So it clearly implies that suppose if we are compressing the piston, or if we are making a work which is based on the compression, that means surrounding is acting on the system. In that case, what happens is the work done is said to be positive. As well as we could see that we are providing heat also. So suppose if we have provided heat to the particular system, so in both the cases, even if we have provided heat, even if we have compressed the piston, or if we have performed a work which is based on compression, so in that case the internal energy will be increased. So this delta U will be nothing but the increase in internal energy that we could observe. So therefore this delta U will be increase in internal energy which is equals to Q plus W, and this Q is nothing but the heat that we have provided. So therefore heat provided to system plus W, that is work done on system. So if we do this both things on, or if we have provided heat or work on the system, then there are the chances of the increase in internal energy. So this is how this implies the first of thermodynamics, means the energy is not been wasted. Suppose if we have increased the internal energy, that internal energy would let us to increase the heat of the system, as well as to perform the work by the system. So that energy plays a very vital role, and this is nothing but the first law of thermodynamics. So let me give you another brief example of this thing. Suppose the internal energy is now being decreased. So what will happen? So if internal energy is being decreased, this is because of the heat is now being moved away from the system to the surrounding. Or else we could see even if the heat has been expelled from the system to the surrounding, and if the gas expands, so now what we could see is as the work is done by the system to the surrounding. So in this case, that would lead to the decrease in internal energy. So somewhere internal energy could be very much capable of doing work, as well as it could also be used for increasing the heat of the particular system. So what are those? We are going to study it now. So for this instance, we have got to know that this is the mathematical expression of first law of thermodynamics. In this case, the energy is being utilized to perform two things, that is to for the heat as well as for work. So the both kind of energies are being utilized, and in this case the change in internal energy is because of the both, that is heat as well as the work energy. So now suppose if we have implied some various factors such as what would be the internal energy if we are talking about an isothermal condition, adiabatic condition, isobaric and isochoric condition. So let us talk about each one, and let us do a brief analysis that what would be the value of internal energy, or what that kind of factors will have effect on the internal energy. So talking about the first case, suppose if the system or if the system is performing a work of an adiabatic process. So if the system has been performing an adiabatic process, then we know that there would be no exchange of heat, or there would be no change of heat. So heat will remain constant throughout the whole process. So in this case, basically Q will be is equals to 0. So suppose if Q is equals to 0, then what would be the internal energy? Because we know that internal energy, that is the change in internal energy, is equals to Q plus W. And if it is an adiabatic process, means when Q is equals to 0, therefore delta U is equals to W. So in this case, the W will be positive. Suppose if we have increased the internal energy, making the system to be performing an adiabatic process, then we could see that all the internal energy would be reason for the work done by the surrounding to the system. So that means in this case, if we would say, if we would do the work on the system by the surrounding, so there would be increase in the internal energy, and in this case delta U will be positive. So that is what they are telling about. So this is a very clear indication that if we want to do work on the system by the surrounding, then there is the increase in internal energy, that is nothing but delta U. So if W is, suppose in this case, is negative, that means it clearly indicates that the system has been performing the work on the surrounding, and in this case the delta U, that is that would be negative, that means it would decrease. So that is what it was telling about. So let us do for what would be the case when we are talking about an isothermal condition. So when we are talking about an isothermal condition, or I would say as isothermal process. So in isothermal process, basically there is no change in the temperature, as well as the temperature will remain constant throughout the whole process. So therefore delta T is equals to 0. So what is actually the role of the temperature in basically in change of internal energy? So let me tell you, if the temperature is not been exchanged, or if the temperature has been kept constant throughout the whole process, then what will happen, will be no kind of exchange of or there would be no kind of increase or decrease in the temperature. This will lead to there would be no change in internal energy, and the internal energy would be remain constant throughout the whole process. So that means what we are talking about is, that is delta U is equals to Q plus W. So because the change in internal energy is because of the heat and because of the work done on the system by the surrounding. So since there is no change in the temperature, that means it clearly indicates that there would be no change in the internal energy also. So in this case, what will happen is delta U will be also 0. And if delta U is 0, so this will be Q plus W. So therefore Q is equals to minus W. We could say in this manner also when we are talking about an isothermal process. So what does this Q is equals to minus W means? It means that suppose if we have provided heat to the system, that is if we have provided plus Q to the system, and if the system is performing an isothermal process, then what will happen actually? The work will be negative. This work will be negative. This work negative indicates that the system will act on the surrounding by performing a work. And yes, we will. And what if, suppose if the work is done on the system? So if work is done on the system, then we could see that the heat will increase, and the heat will liberate out, and the heat will be of minus, because if we want to convert the work to be positive, obviously the heat will be removed or been expelled from the system. So this is what this clearly indicates, that if we provide heat, then the work done on the surrounding by the system will be more, and this is what vice versa when we are talking about Q is equals to minus W. So now let us talk about what would be the case when we are talking about an isobaric process. So in isobaric process, as you know that the pressure will remain constant, so there will be no change in pressure. So therefore in this case pressure is constant, I would say in this manner. So therefore what would be the formula, or what would be the change in internal energy? That is delta U is equals to Q plus W. That is what we know. But we can also write the equation as Q is equals to P delta V. And in this case, because the pressure is not being changing, or pressure is being set to be constant, so the heat that we are talking about, that is the value of Q, it will also remain constant with respect to the pressure. So I will name it as QP, and this is delta U. So now this clearly indicates that if we want to change the internal energy of the system, so that would should be the change in heat, that is QP at constant pressure, and yes, the volume will also also be changed. And but the thing is, if we have to increase the internal energy of a particular system, then the work should be done on the system by the surroundings, so as the work should be the positive one, and because of which the heat of the system will also increase, and in a manner of fact, internal energy will also increase. So this was related to an isobaric process when we are talking about, or when we are applying the mathematical expression of first law of thermodynamics in this condition, that is an isobaric process. So now let us talk about the last factor that we have, that is isochoric process. What will happen in that thing? So as we know that in isochoric process, basically there is no change in volume, so therefore the delta V will be 0. So there is no change in volume, and if we apply this the first law of thermodynamics, then we know that delta U is equals to Q plus W, but this W can be written as P delta V, because the work is nothing but a pressure volume work that has been performed, and because there is change in volume, as we could see, as well as we have made an example of that earlier also in deriving the equations, like the work done during the expansion of gas, as well as the reversible process in isothermal, that is the work during expansion of gas. So in that process, what we have got to know that the work is been dependent on the pressure as well as on the volume, and in this case, because there is no change in volume, as we could see, so therefore, so this delta V will be 0. So overall the whole P into V will be 0, and this is the delta U. So this is, but this is the condition when we see the volume is said to be constant. So therefore this equation now will be turned into delta U is equals to QV. So this clearly indicates that if we are making, or if we are keeping the volume of the system to be constant, and if we are providing heat, so all the heat that we are providing to the system at a constant volume, that will increase the internal energy, and all those heat energy will be occupied with the, or the internal energy will be equal to the heat that we have provided to the system. So but this will be only possible if we are considering the isochoric process. So this were all the systems that we are talking about, and all the kind of process that we have applied on the first law of thermodynamics. So thank you friends for watching this video. I hope you have liked this video and you have understood what is the first law of thermodynamics, its statements, its mathematical expression, and its application on the various processes. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.